This is SpaceTime, Series 28, Episode 82, for broadcast on the 9th of July 2025. Coming up on SpaceTime, the largest Oort Cloud comet ever observed. NASA's Mars Perseverance rover sets a new distance record on the red planet, and the discovery of planets that can trigger stellar flares. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have made a groundbreaking discovery by detecting molecular activity in the Comet C 2014 UN271 Bernardinelli-Bernstein, the largest and one of the most distantly active comets ever observed originating from the Oort Cloud. The findings, reported in the astrophysical journal Letters, are based on observations from ALMA, the Atacama Large Millimeter Submillimeter Array radio telescope in Chile. The Oort Cloud is a hypothetical sphere or region of frozen worlds, comets and icy debris caught up in the Sun's gravitational field out beyond the solar system. It occupies a region of interstellar space stretching more than a light year from the Sun, and it includes debris floating around in interstellar space as well as celestial bodies torn away from other star systems by the Sun's gravitational pull. Astronomers studied this giant comet while it was still more than halfway to Neptune, at an astonishing distance of 16.6 times the distance between the Sun and the Earth. Comet Bernardinelli-Bernstein is a true behemoth. It measures nearly 140 kilometres across. That's more than 10 times the size of most known comets. And it's a fascinating celestial object to study. See, until now, little was known about how such cold, distant objects behave. The new observations have revealed complex and evolving jets of carbon monoxide gas erupting from the comet's nucleus, providing the first direct evidence of what drives its activity so far from the Sun. The study's lead author, Nathan Roth from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says these measurements are giving scientists a close look at how this enormous icy world works. Astronomers are seeing explosive outgassing patterns, which are raising new questions about exactly how this comet will evolve as it continues its journey towards the inner solar system. ALMA observed Comet Bernardinelli-Bernstein by capturing light from carbon monoxide emissions in its atmosphere and thermal emissions when the comet was still a long way from the Sun. ALMA's high sensitivity and resolution allowed scientists to focus on the extremely faint signal from such a cold, distant object. Building on previous ALMA observations, which first characterized the large nucleus and size of the comet, these new findings measured the thermal signal to further calculate the comet's size and the amount of dust surrounding its nucleus. And their values of the nucleus's size and dust mass are in agreement with previous ALMA observations, and therefore confirm it as the largest known Oort Cloud comet ever found. The discovery not only marks the first detection of molecular outgassing in this record-setting comet, but it also offers a rare glimpse into the chemistry and dynamics of objects originating from the furthest reaches of our solar system and even beyond. As the comet approaches the Sun, scientists anticipate that more and more frozen gases will begin to vaporize, revealing even more about the comet's primitive makeup and the early solar system. And these sorts of discoveries will help answer fundamental questions about where Earth and its water came from and how life-friendly environments might evolve elsewhere. This is SpaceTime. Still to come, NASA's Mars Perseverance rover sets a new distance record on the red planet, and the discovery that planets can trigger stellar flares. All that and more still to come on SpaceTime. NASA's Mars Perseverance rover set a new distance record of autonomous travel as it continues exploring the rim of the red planet's Jezero crater. The car-sized six-wheeled mobile laboratory travelled 411 metres in a single drive, guided only by its auto-nav self-driving system. It also undertook its 30th abrasion study, drilling into a Martian rock named Kenmore. It abraded a 6-centimetre wide patch, then cleared the debris with its nitrogen-powered gaseous dust removal tool. This device delivers 5 puffs of gas per operation, enabling mission managers to penetrate below the weathered exterior of the rock and examine the pristine mineral composition of the interior. Perseverance Deputy Project Scientist Ken Farley from Caltech says Kenmore was a weird, uncooperative rock that vibrated excessively and shed fragments during the grinding. Following the abrasion, Perseverance used its Watson imager to undertake a detailed observation of the rock, while at the same time its SuperCam instrument used lasers and spectrometers to examine both the abraded rock and the adjacent tailings. This revealed clay minerals with hydroxide groups bound to iron and magnesium. Previous rock samples had produced similar findings, which are typical of ancient Martian geology. But SuperCam also identified elevated levels of iron and magnesium. Subsequent analyses by the Sherlock and Pixel instruments confirmed the presence of clays and also feldspar, and it detected a magnesium hydroxide mineral for the first time. These new discoveries will help deepen science's understanding of the Martian geologic history. This is SpaceTime. Still to come, astronomers discover that some exoplanets on tight orbits around their host stars can actually trigger stellar flares. And later in the science report, a new study confirms that some websites are covertly using browser fingerprinting to track you and your activity across different browser sessions. All that and more still to come on SpaceTime. Astronomers have discovered that some exoplanets on tight orbits around their host stars can actually trigger stellar flares on those stars, resulting in a sort of planetary death wish. This is the first ever evidence of a planet triggering stellar flares. The observations, reported in the journal Nature, were made using the European Space Agency's CHEOPS, pronounced CHEOPS, spacecraft. Stellar flares are powerful blasts of energy erupting from a star's surface. The new observations found that these tremendous explosions are blasting away the orbiting planet's wispy atmosphere, causing it to steadily shrink over time. Though this was all theorized to be possible long ago, the flares seen in these observations are around 100 times more energetic than anything that was expected. Thanks to observatories like the Webb Space Telescope and NASA's Transiting Exoplanet Survey satellite TESS, astronomers are already seeing interesting clues about this planet and the star it orbits. By the way, the star, named HIP 67522, was already known to be slightly larger and cooler than our Sun. But while at 4.6 billion years old, our Sun is considered to be middle-aged, HIP 67522 is still just a kid at a mere 17 million years of age. So far, astronomers have detected 2 planets orbiting the star. The closer of these 2 planets, HIP 67522b, is a so-called hot Jupiter, a gas giant taking just 7 Earth days to orbit around its host star. Now, because of its youth and size, scientists think that this star probably churns and spins with lots of energy, and this churning and spinning generates powerful magnetic fields. Now, our much older Sun has its own smaller and peaceful magnetic field. And from studying the Sun, astronomers already knew that solar flares of energy can burst from stars where magnetic field lines are twisted and suddenly released. Now, this energy can take the form of anything from gentle radio waves to visible light, right through to aggressive X and gamma rays. Ever since the first exoplanet, Pegasi 51, was discovered back in the 1990s, astronomers have pondered whether some of these exoplanets might be orbiting close enough to disturb their host star's magnetic fields. And if so, could that trigger a stellar flare? And a team of astronomers led by Katerina Ilin from the Netherlands Institute of Radio Astronomy Astron wanted to investigate this question further. Ilin says scientists hadn't seen any systems like HIP 67522 before. And when the planet was found, it was discovered that it was the youngest planet to be orbiting its host star in less than 10 Earth days. Ilin and colleagues were using tests to do a broad sweep of stars that might be flaring because of an interaction with their planets. And when TESS turned its eyes on HIP 67522, the authors thought that they may well be onto something. So to be sure, they called upon the talents of ESA's CHEOPS spacecraft. CHEOPS can target individual stars on demand with ultra-high precision. CHEOPS observed a total of 15 stellar flares, almost all coming in our direction as the planet transited in front of the star as seen from Earth. And because the flares are being seen as the planet passes in front of the star, it's highly likely that they were being triggered by the planet itself. As we mentioned earlier, a flaring star is nothing new. Our own sun regularly releases bursts of energy as solar flares, which we experience here on Earth as space weather, geomagnetic storms. This causes colourful auroral activity, usually at higher latitudes. But it can also cause damage or destruction to spacecraft, interfere with communications and navigation systems, increase the radiation dosage of people in space, and even overload terrestrial power lines, triggering blackouts. But astronomers have only ever seen this energy exchange between a star and a planet as a one-way street from the star to the planet. Knowing that HIP 67522b orbits extremely close to its host star, and assuming that the star's magnetic field's strong, the authors have deduced that the clingy planet is orbiting close enough to exert its own magnetic influence on the star. Lynn thinks that the planet gathers energy as it orbits, and then redirects that energy as waves along the star's magnetic field lines as if it's whipping a rope. And when the wave meets the end of the magnetic field line at the star's surface, that triggers a massive flare. Now, it's the first time astronomers have seen a planet influencing its host star in such a way, and that overturns previous assumptions that stars behave quite independently. And not only is HIP 67522b triggering stellar flares, it's also triggering them in its own direction. And as a result, the planet experiences 6 times more radiation than it otherwise would. Now, unsurprisingly, being bombarded with such high-energy radiation does not bode well for the future of the planet. HIP 67522b is similar in size to Jupiter, but it only has the density of candy floss, making it one of the, well, I guess you'd call it wimpiest exoplanets ever found. Now, over time, the radiation is eroding away the planet's feathery atmosphere, meaning it's losing its mass, which is degassing into space, much faster than what would be expected normally. The authors estimate that within the next 100 million years or so, it could go from being roughly the size of Jupiter to something much smaller, about the size of Neptune. Lynn says the planet seems to be triggering especially energetic stellar flares. The waves it sends along the star's magnetic field lines kick off flares at specific moments, but the energy of the flares is much higher than the energy of the waves. When HIP 67522b was found, it was the youngest known planet orbiting so close to its host star. Since then, astronomers have spotted a couple more similar systems. There are probably dozens more in the nearby universe. ESA's CHEOPS spacecraft was specifically developed to fill a unique role in astronomical observations. This report on its construction from ESA TV.
Since all its elements have already been proven in flight, this is a low-cost, low-risk mission. But it has high ambitions. CHEOPS is a mission with a single instrument, a powerful camera or photometer that will record the light from an exoplanet star. And its aim is to determine the nature of known exoplanets outside our solar system.
We'll be focusing on smaller planets, so Earth-sized to Neptune-sized planets, which have been found by other missions, such as Kepler, to be very abundant around other stars, sun-like stars, something which is not so much the case in our own solar system. So it's a big question. What are these smaller planets? What are they made of? And with CHEOPS, that is what we are aiming to discover.
To do this, CHEOPS will measure the variation in light caused by an exoplanet transiting in front of the host star to determine the planet's size. Since we already know the planet's mass from measurements made with other telescopes, scientists combine the sizes measured by CHEOPS to work out the density, which will show whether the planet is rocky or gassy. They can then learn more about its composition and also its formation and evolutionary history. CHEOPS orbits 700 kilometers above the Earth in such a way that its camera will always point towards the night side. This dusk-dawn orbit will limit any sunlight or stray light from Earth, disturbing its measurements, as it's a technical challenge to obtain precise measurements of light from stars outside our solar system.
Is not easy, and the instrument was designed to be able to perform accurately over long periods of time, and the satellite was designed around the instrument to guarantee these stable conditions. As an example, stable thermal conditions. The satellite has a sun shield protecting the instrument from the direct sun illumination. And this is very important to allow the proper thermal stabilization of the detector inside the instrument.
CHEOPS, a partnership between ESA, Switzerland and member states, has a long journey of discovery ahead. This mission will not only give us key information about the nature of known small exoplanets, it could identify those with the potential to host life.
And in that report from ESA TV, we heard from ESA CHEOPS project scientist Kate Isaac and ESA CHEOPS project manager Nicola Rando. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has confirmed that recent warm summers in the Antarctic have led to record lows in sea ice in the region. The findings, reported in the journal PNAS Nexus, are giving scientists a window into the future impacts of climate change. The authors looked at how recent summer sea ice extremes have impacted on ocean currents, on ice shelves, on the wildlife, and even shipping access. The authors say the research is improving science's understanding of what to expect as these extremes become more common, with sea level rise, ocean warming and wildlife loss among the likely scenarios. A new study has shown that people who received the COVID-19 vaccines available in 2023 and 24, they targeted the XBB 1.5 Omicron variant, wound up getting increased protection from hospitalisation and critical illness, well above the general immunity from previous vaccines and infections. A report in the Journal of the American Medical Association looked at data from almost 350,000 emergency department presentations and more than 100,000 hospitalizations in the United States to find COVID-19 patients and estimate the effectiveness of the vaccines in circulation at the time. They estimate that on top of the protection against COVID-19 most people now have from prior vaccinations and getting the virus, the vaccines were 29% more effective against emergency department presentations, 30% more effective against hospitalization, and 48% more effective against critical illness, with vaccine efficiency highest from 1 week to 2 months after vaccination. A new study has confirmed that websites are covertly using browser fingerprinting to uniquely identify a web browser and then track you across your different browser sessions and sites. The findings were published as part of the proceedings of the ACM on Web Conference 2025. They show that clearing your cookies simply isn't enough to protect your privacy online. See, when you visit a website, your browser shares a surprising amount of information about you, including your personal web address, your screen resolution, your time zone and location, and your device details. When all combined, these go on to create a digital signature or fingerprint that's unique to your browser, consequently unique to you. Unlike cookies, which users can delete or block, fingerprinting is much harder to detect or prevent. Fingerprinting's always been a concern in the privacy community, but until now, there's been no hard proof that it was actually being used to track users. Most users have no idea it's happening, and even privacy-focused browsers are struggling to fully block it. Samsung will be launching its new Galaxy Z Fold and Flip 7 phones in New York at midnight tonight, Australian Eastern Standard Time. Now, although the details won't be known until then, technology editor Alex Zaharov-Reutt from TechAdvice.life says the rumours are all very specific.
Samsung will hold its Unpacked event in New York, and they will be launching the latest versions of their Flip and Fold devices. Now, Samsung has already teased that these are going to be thin and light and ultra for the Fold, and so we should expect to see, like with the Samsung S25 Edge, a super thin device that will be very thin when it's opened, and it will be also thin when it's closed, because you do want to have a device that isn't like two smartphones stuck together. And the questions are going to be, what is Samsung going to do to turbocharge its lead in AI over competitors like Apple? I mean, it's obviously leaning on a lot of what Google has done with Gemini Live. We're talking about the rumors saying that there'll be a 6.5-inch screen on the Fold on the outside, which is sort of previously the screens were quite narrow and people didn't like that. And then inside it should be like an 8-inch screen. I mean, none of this is confirmed officially yet, but there's obviously plenty of leaks online that potentially have come from Samsung itself. But there's all sorts of stats and specs that you can see. And, whether there's going to be a price rise because of the tariffs or even a price cut because Samsung wants to capture as much of the market as possible is yet to be seen. There have been reports that Samsung will actually lower production of both the Flip and Fold this year because they just haven't sold as well as intended. But if Samsung can make a device that's thinner than ever, cost competitive, introduce more multitasking features that take advantage of the fact that you have a Flip device and a Fold device, well, all those things could very well see these devices be more popular than ever. And of course, we do have competition from people like Motorola, who have their Razr devices that are very keenly priced, cheaper than Samsung's Flip. And then with the Fold, of course, we have the Fold device from Google, there's Fold from Oppo, and of course, we have the triple folding device from Huawei that hasn't been launched in the West, but of course is available in China and is a technological marvel. Now, Samsung did showcase a folding screen without a crease at one of the big display events that it holds, but there's no knowledge yet as to whether that's going to be officially launched this year. But even so, even if that doesn't come this year in their commercial device, the crease should be as shallow as we've ever seen it. I did see on the Pixel Fold, for example, that the crease was a little bit deeper than you would see on a Samsung device. And that's probably because, Samsung makes the screen for the Pixel Fold. And so, it's saving the best technology for itself. And there's also no word as to whether Samsung is going to launch a tri-fold device this year. Probably not this year, probably next year or sometime in the future. And there's also talk as to whether Samsung will release both the FE or Fan edition for both the Flip and the Fold, which would be cheaper devices, obviously not as slim and sleek as the Fold and Flip 7, but more affordable, which would obviously boost interest and boost sales. So look, we'll have much more to talk about this, when all the news is official, but you can expect that given Samsung has really stretched out with the Samsung Galaxy S25 Edge 5.8mm device, we should see that when unfolded, these devices will be even slimmer. And of course, they have to then fold into a thicker device. And so it'll be interesting to see just what they were able to do, given that competition from Oppo and others has already showcased and produced very thin devices that, when folded, feel like traditional smartphones.
That's Alex Zaharoff-Reuter from techadvice.live. And he'll have a full detailed report on the event and the release in next week's show. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.